Okay, the next method of finding yp we call operator method. So under this method, I'll talking about another three sub-methods. Okay, the first one we call successive integration. The second one we call partial fraction decomposition of operator, and the last one we call shortcut. Okay. Before we learn all three techniques, we got to learn the definition of the operator sign, which is the capital D there. Whenever we write a capital D and then times y, the meaning is dy by dx. So if we put this square times y, it means the second derivative of y by dx. So if we have c to the power ny, it means the nth derivative of y by x, just like that. So what if we say dy and yd? I want to say that dy and yd are not equal, so they don't have the property of switching position. Okay, because dy it means dy by dx, yd it means y times d number 1 by dx, which is equal to 0. So these two are not the same, okay, are not equal. So if I have the n order of non-homogeneous differential equation with the constant coefficient, just like this, I'm going to write this equation in the form of operator D. Then I will get this line, right? Because we know that the n derivative of y by dx is equal to d to the power ny, right? So the other term, you just repeat that the form, you would end up with this. This equation, you have y in each term, so we take y out. If we take y out, we got to take it out behind this form, right? If we take y out and then we put at the front of this term, the meaning would be the same as this one. But for our equation, y is just behind d. So when you take it out, you've got to put it on the back. Okay? And the term which is inside the parenthesis there, we would call it PD. P and then parenthesis D, it means a function of D. D is the operator. And then if we want to find y, we got to time this equation with 1 over PD. But the thing is that because D is the operator, if you put 1 over PD in front of the term PD times y, on the function x side, you got to put 1 over PD in front of fx too. Now the position is important. If you put 1 over PD next to y, it wouldn't cancel out with the PD in front of y. So that's why you got to put 1 over PD next to the PD. You just can't put this term right there behind y. If behind y, then it wouldn't cancel out because they don't have the property. Okay? But when you put 1 over PD right here, because it's next to PD there, you just cancel it out because they are the same thing. Okay, so we would end up with y, so is equal to 1 over PD times fx. We call 1 over PD as inverse operator. Now we are going to define each term of 1 over PD. We consider this one first. If we have dy is equal to fx, the meaning of this one is dy by dx is equal to fx, right? When we have dy, this dy it means first derivative of y with x. In order to solve for y, this one, in order to find the solution of y for this equation, the way that we do it is we put dx to fx, right? And then we do integral for both sides, and we get y is equal to integral fx dx. But this one, in order to find y, you time this equation with 1 over d, right? Right? And 1 over d and d there just cancelled out. So you've got y is equal to 1 over d fx. But these two are equal because they are the same equation. So from this, we would say that if we have 1 over d times fx, the meaning is just equal to integral fx dx. That is the thing that we got to remember. So if we have 1 over d times fx, the meaning is just that integral that fx with that. Now, if we consider another term, what if we have 1 over d squared fx? The meaning is just that and 1 over d fx is mean integral fx dx. And 1 over d, now the integral fx dx is equal to another function of x. For example, if it's equal to gy. So 1 over, dx. 1 over dx. 1 over d times dx is equal to integral gx dx. So that means it's become a double integral. Now if you have 1 over d to the power n, it means you are going to do successive integral for n times. Integrate อย่างสืบเนื่องทั้งหมด n ครั้งนะคะ successive integration n time. If you have 1 over d to the power n fx, that means you've got to do integral for n times. That's the meaning. Now what if we have 1 over, b minus a y equal to fx. The meaning of this is right, which is this is the first order differential equation. And what type of equation is it? It's a linear. So the way to find the solution of this is you got to find integrating factor, right? Integrating factor is equal to this term, right? So you know y is equal to 1 over mu integral qx dx. Right? This one is minus because it's the integrating factor. But if you want to solve this one, you got to time this one with these two are equal. So that means 1 over d minus a fx equal to that is the second formula. So if we change from d minus a to d plus a, we would get that is from the operating method, operator method. Do you know the meaning of 1 over d fx? Do you know the meaning of 1 over d minus a times fx? And you know the meaning of 1 over d plus a fx? So whenever you're writing down the differential equation in the term of operating operator d, then you just use this definition to find the answer for it. Like I said from the beginning that with this method we are going to divide it into three methods, three sub-methods. The first one is called successive integration. This saying that if we want to use the successive integration, you got to write down your differential equation in the term of PD. Y is equal to fx. And then if PD, which is equal to A0, A1, I'm sorry, and then your PD can write down in this term. Then we can use our definition, the definition that we just find out to find the solution. Okay? If PD can be written down in this term, then we would get y is equal to 1 over PD times fx, which is 1 over times fx, right? And then you know that the meaning of 1 over g minus r or minus a is equal to integral term. So you can find yp. This one is yp. You can find yp by putting the definition that we just make up there into each term, and then you do successive integration, and then you would get the yp. Okay. Let's take a look at the example. It may be easier to understand. For example, if we have the equation like this, we have fx is equal to exponential of 2x divided by x squared. With this equation, can we find the yp solution by using the UC method, the undetermined coefficients method? Can we use the technique to find yp? Can we? No, we can't. The reason why we can't is because 1 over x squared is not a UC function. UC function saying that if it is a polynomial, then the power of x got to be positive integer. But this one is negative. So you can use the UC method to find the yp. So in that case, you got no choice, because this is just the only second method that you learn. So you cannot use other technique now, because you just learned that technique, which is UC, and this is the second one that you are learning. So we are going to use our second method to find the yp of this differential equation. So this is a non-homogeneous equation, so the answer would compose of yc and yp. To find yc, you've got to find the characteristic equation, which is m squared minus 4m plus 4 equal to 0. So you find 2m, which is 2 and 2. It's a repeated real root. So for repeated real root, what is yc? Now to find yp, because we are going to use the operator method. So with that method, you've got to write your differential equation in the term of operator d, right? So the way to do that, change to the capital D, you would get d squared minus 4d plus 4y equal to so y is equal to y over our PD can write down in this term d minus 2 and d minus 2. In order to find y, we got to use the definition of 1 over d minus a that we just find out, which is equal to exponential of 2x integral exponential of minus 2x times dx. Exponential of minus 2x times exponential of 2x is equal to 1. Now the integral term, you have only 1 over x squared dx. Integral 1 over x squared dx is equal to minus 1 over x.